Good afternoon. It's Monday, August the 31st. Today we looked at section 2.1 and talk about power functions. I will share the screen and show you a little bit about what that looks like. Okay, with a power function, you have a function y. You have y equals some constant times a variable x, normally in this case, to some power b. Okay, so if you notice, this is what's called a power function. There is no constant term, so the x and y intercept of the power function will be the origin. Now, an example here, we have y equals 3x squared You know what the x squared function looks like? It looks like a parabola, or it is a parabola. And it goes through the origin. Now the 3, remember the 3 makes it a little bit higher, so we go through the origin here and it would come back up like this. Instead of being at the point 1, 1, this point right here would be 1 and 3. So we looked at the square function last chapter. We looked at the third degree function. So if we look at a different type of function, we can come down here and say, okay, we have y equals, let's say, 3 to the 3x to the 5/2 power. Now, see, if I do a 5/2 power, that's the same thing as saying 3 times x to the 1/2 raised to the 5th power. So we know what x to the 1/2 looks like. X to the 1/2 remember starts at the origin and goes up into the first quadrant. X to the 1/2 goes up like this. So if I take the normal point, which is right here, this normal point here would be 1, 1, and now it's going to be 1 and 3. So we take this and we multiply this by 3, but before we do that, we'll raise it to the 5th power. Now, if you remember, this point right here is y equals 1. So any number less than 1, which are all these in here, if I raise it to a power greater than 1, the numbers get smaller. So if I come in here and look, so anything in here between 0 and 1 is going to get smaller as I raise it to the 5th power. And then all these things outside here are going to get bigger. So this basically is going to look something like that, if I could draw a straight line. And then I multiply it by 3, it just makes it 3 times as tall, okay? But when you're looking at these power functions, especially these rational exponents like the 5/2 or something here, if you get to the point where you can break it down, like I did here, to something, one of the parent functions like x to the 1/2, you know what it is, you can generally kind of put it back together and figure out what the new function will look like. Okay, so I'll stop sharing here. If you look at your homework assignment, check and see if you have any questions. Look back at the examples in the section. Now tomorrow we will look at the radical exponents. So those are something that the latter part of the section. But look at your homework. If you have questions, send me an email and I'll get back to you on it.